Hello everyone, welcome to the next lecture. That's a part 2 on the PYQ questions on calculus of variation. Today we will discuss all those questions from the year 2021 to 2023 with the help of shortcut trick. Myself, Dr. Harish Garg. You can simply follow my YouTube channel or else you can simply scan and join my WhatsApp group. What you will be found on my YouTube channel, you can see there is a playlist of the CSIR UGC net where you can find the PY question on the integral calculus from the year 2011 to 2023, PY question on the calculus of variation, that's a part 1, PYQ questions on the eigens value, linear programming problem, optimization techniques, differential equations, statistics, as well as the complete previous year solutions are here. So we will see how you can solve the calculus of variation from the year 2021 to 2023 with the help of shortcut tricks. In this lecture, we will describe the 25 plus questions, while the other previous availables at my YouTube channel, Dr. Harish Garg. So what is the tips for you? Once you have the functional here, depending upon the nature of this, if it is a function of the x, y and y dash, you can start with the Cauchy-Euler, that is called as the Euler-Legendre equation. If this function is independent of the x and y both, then there is always a solution of this form, whatever the nature of this. If this function is independent of the x only, then we can start from here. If this function is independent of the y only, then we can start from here. If this is independent of y, then this is my constant. So these 1, 2, 3 are the simple tips for you. So let's start with this one. Now here we can start with this Cauchy-Euler minus partial of y dash. So what is that? This is 12x minus, this is my minus 2y dash is 0. So what is that? This is 6 plus 6x plus y double dash is 0. What is the meaning of that? Y double dash is minus of 6x. Now you can look about the options. What is the second derivative of this? It's a 2 which is not equal to minus 6x. Here this is the x raised to power 4 whose derivative can never be minus of 6x. Again this is the 4. This is minus x cube, so the derivative is my minus 6x is the right answer of this problem. Now look at this one, which of the following statement is true. Now here they are asking about some condition. In the previous question they are asking about the extremal. What is the extremal? So you have to solve this problem. But here they are not asking about the extremal. What is that? Y is always. The word is always even order. So consider any of the even order. Say x4, this is my even order. Now what is the y of minus 1? Is satisfied? Yes. Y of 1 satisfied? Yes. If you substitute here, what is the value of this? X raised to power 4, that is 2 over 5. If you integrate them, 2 over 5 which is not equal to 1, it means of any order is cancelled. Second option is always even order, so you can consider this is my x, this is the odd order. Now is it satisfied this condition? No, y of minus 1 is not equal to 1, so this option is also cancelled out. Now what is the y is unique? If it is unique, then it is either the odd polynomials or the even polynomial. But from the second and the third option we see it can never be the odd, it can never be even, so it means it can never be a unique. So this option is also cancelled. Right answer is only D is my correct option. Okay, look about this one. So again, which is the function of the x and y both. So we can start with this one, minus partial derivative y dash is 0. So what is the partial derivative with respect to y? Is a y dash minus, what is the partial derivative with respect to y dash? Is minus here and plus 1 plus y. So now if you take partial derivative with respect to x, minus minus plus, it is x minus y dash, and it is 1 minus y double dash minus 0 minus y dash is 0. Now clearly say it will be cancelled out. Exponential can never be 0, so it means 1 minus y double dash is 0. That is y double dash is my 1. So what is the meaning of that? So therefore if you integrate them, it is my x plus a. If you again integrate them, it is x square by 2 plus ax plus b. Now y of 0 is 0, it means b of 0. When y of 1 is half, so it is my half plus a by 2 plus 0, a is also 0. So what is the solution of this? Solution is my x square over 2. Now what is the right answer of y of half? So what is the y of half is 1 by 8 is the right answer of this problem. Now which of the following is here? So I can write this function as 3xy minus y square. Now we can start from here, partial derivative and over this one. So what is the partial derivative is 3x minus 2y. This part is my 0, so partial derivative is also 0. So y is 3x over 2. Now check whether this condition satisfied or not. What is the y of 3? 9 over 2. It can be written here, so this is satisfied. What is the y of 1? Is 3 over 2, which is not equal to 1. It means this extremal not exist. So if there is only one extremal, so it means the no solution exists for here. Now look at this one. I can written this f as this is my y dash square minus y square, which is independent of x. Then we can start with the solution as of this one, which is constant. So what is the f? Y dash square minus y square minus y dash. What is the partial derivative of this is 2y dash is c. What is the meaning of that? Y dash square minus of 2y square, that is a minus y dash square minus y square is, so what I can written as y dash square plus y square is my constant. Or if you look about, you can also start from this case b if you want. That could be easy or for you, that's on your choice b. So what is the partial derivative? Minus of 2y. What is the partial derivative? Is 2y dash is 0. So what is the meaning of that? Y double dash plus y is equal to 0. So the solution is c1 cos x, c2 sin x from here. Now y of 0 is 1. Y of 0 is 1, it means c1 is my 1. Fine, because sin 0 is 0, cos 0 1 is here. What is the y of pi by 2? So it is 1. It is c1 is 1, cos of pi by 2 is 1 is 0. So again it is 1 is 1. So what is the final solution? Cos x plus c2 sin x. This is my final solution. Now you can see this c2 has infinitely many value, so the corresponding y has infinite many values. So the right answer is an infinite number of solutions. Now again we can start with extremals, which is, so partial derivative with respect to y, so it's a 2y minus partial derivative with respect to y dash here. So what is the right answer of this? 3x square. So y is equal to 3 over 2 x square. So what is the nature of this? Is a quadratic. This is the right answer of this problem. Okay, which of the following is a weak minima, weak maxima? Now again there is no need to solve them. What is the condition for the weak minima and maxima? If you find of here, if it is greater than 0 for all x or for all the extremal, then we can say it's a strong. If it is greater than 0 for some x, then we will call as a weak. Otherwise weak minima, strong minima. If it is less than 0, then we call as a maxima. So what is that? F is my y dash square plus x square. What is the partial second order partial derivative of this? 2, which is greater than 0 always. So what is the meaning of that? It has a strong minima. Once is a strong minima, so it means it is also as a weak minima. But converse is not true. Strong minima and the weak minima. So weak minima and strong minima. So these are the correct options for this product. Okay, look at this one. So what is the f is my, this is y dash square plus y dash cube. So clearly says that this is independent of x and y. So what is the solution of this? It is always be a constant. That is a linear form, always. Whenever there is a function of independent of x and y is always here. Now you know what is a c1? That is a one time differentiable. So you can see that this is a polynomial and every polynomial is differentiable over the c1, c2 and so on. So there exists an extremal in c1, that's true, not c2, that's false. This is again not, that's false. every extremal of y belongs to the C1, that's 2 because it's a one-time differentiable. It is also the two-time differentiable. Moreover, it is also the three-time differentiable and so on. So the right answer is C and D. Now here, how you can solve that? Again, you can see this is a function 1 plus y square over y is independent of x. So we can start with here. Partial derivative is constant. So what is the f is 1 plus y square minus, what is the partial derivative of this? Minus 2 over y dash cube is 0, is a constant, sorry. So minus minus plus, it will be cancelled out. So 1 plus, that is a 3 times 1 plus y square over is a constant. So I can return this one as 3 over c is y dash square over 1 plus y square. I can take a square root. I can consider this as a constant. So this is my y dash over 1 plus y square. Now I can integrate them. Once you will integrate, it is ax plus b. What is the integration of this? That's a sine hyperbolic inverse of y. So what is the answer of the y? Y is sine hyperbolic inverse of ax plus b. That's the right answer. You can see because a is my constant, so you can return here. Now there is one more hyperbolic here. If you open them, what is that? This is, sorry, sine hyperbolic. So if you open them, what is that? Sine hyperbolic ax cos hyperbolic b plus cos hyperbolic ax into sine hyperbolic b. Now we know b is my constant, so cos hyperbolic b is also constant, sine hyperbolic is also a constant. So if I consider this as a, so a sine hyperbolic ax, b cos hyperbolic ax is the right answer by taking a as a 1 and b as a constant. In this both cases, hyperbolic is not there. So we all know, if I just write for you, if I just replace this one. Now we all know what is the sine hyperbolic of iota x is iota sine hyperbolic x. So if I just simply consider sine of this, if I look from here, if I simply take a as my iota, b as my 0 in this case, what is my y? Sine hyperbolic iota x. I can written as iota sine of x. So if I consider this is my a, then a sine x, this is the right answer. If I just consider, if I just open this bracket here, then what will happen of this? Again, if I just replace here iota x, so what is the sine of hyperbolic iota x is my a times iota sine x. What is the cos hyperbolic iota x? It is nothing but my cos of x. So this is same, and in this case if I replace a to be the a iota, so that is also the right option. So all are my correct option. Okay, in this case they are not asking about the extremal. So firstly I can write this one as of here. Now which of the following is the minimum? So I can substitute this value here, I can substitute this value here, and we will check the minimum. What is the y dash? 1 by 4. So what is the answer of this? 1 by 4 minus 1 square. What is the y dash? Minus 1 plus 1. If we substitute minus 1, answer is 0. If you substitute plus 1, it's a 0. So definitely this is a non-zero, so this option is cancelled out because we get a minimum as here. What is the y dash is? 2 minus 1. So what is the answer is? 4 minus 1, 3 square, 1 minus 1, 0. So clearly says that this 0 is the minimum as of this 9. So this option is also cancelled out. What is the y dash? 1 minus 1. So the derivative is a 0 minus 1, 1 minus 1, 0. So the right answer is B and D, both give you the minimum answer. Okay, so here you can see this is my independent of, if f is my here, which is independent of y. So once it is independent of y, we can start from here as a constant. So what is the derivative of this? 1 over 2 times 1 plus y square, and 2 times y dash is constant. So 2 will be cancelled out. I can written as e raised to power x y dash. Constant is my say c 1 plus y dash square. So I can put up a squaring on the both side, e raised to power 2x c square 1 plus y dash square upon y dash square. So I can written this number as e raised to power 2x minus 1 minus c square over c square is 1 over y dash square. So I can written as y dash is c square e raised to power 2x minus here. Now you can integrate them. What is the integration of this side? Now you can see about the option. So any function which is x square, no, it's not x square. So if I simply take e raised to power x as a t, so it will be c over t square minus 1 over here, this one. So what is that? This is secant inverse t by c. That's the right answer of this problem. T is my e raised to power x. So this is a 10, this is a 10. This is not true. Here is e raised to power x must be there, and only when t is less than of the c, that is here. So none of the option is correct answers, or there is a typing error. Okay, which of the following is extremal, minimum or maximum? So we can start from here. Partial derivative with respect to y. So 2y dash minus 32y. Partial derivative with respect to y dash. 2y dash plus 2y is 0. So I can take as a 2 as a common and cancel out. So it is a y double dash minus y dash is 0. So it means y double dash plus 16y is 0. So it means y is equal to c1 cos 4x c2 sine of 4x. Now y of 0 is 0, it means c1 is 0. Y of pi by 8 is 1, it means c2 is my 1. So the solution is sine of 4x. Now whether it's a maximum or minimum, how we can find that? How you can find the maximum and minimum? We can start from here. If it is greater than 0, it's a minimum. It's less than 0, maximum. What is the second derivative of the y dash? It is 2, which is greater than 0, so it's a minimum. So this option is cancelled out. Here is the right answer. There is an extremal which is not a minimizer. That's not a minimizer, that means it's a maximizer. That option is also cancelled out. There exists an extremal of j which is not a maximizer. That's true, because we get a minimum are there. So which is not a. So right answer is first and fourth. Now you can see what is the f is y double dash square minus of 2y. So we can write the extremal of this case minus partial derivative of this, but it is a second derivative, so it's a minus plus second derivative of here. If there is a third derivative, you can write this plus minus of here is 0. Now we can substitute it. What is the partial derivative? Is minus of 2. This is my 0. What is the partial derivative of this? Plus. What is the second derivative of this? Is my 2 y 2. Sorry, it's a here single. What is that? This is a 2 y dash is 0. So what is the second derivative of this? Y of fourth derivative minus 1 is 0. That means fourth derivative should be 1. So what you can do that? If I simply take fourth derivative to be a 1, it means you can take the fourth derivative easily. So what is the meaning of that? It is a x cube fourth derivative upon with this condition. Okay, this condition satisfied all. What is the natural condition? Natural condition is, because it's of the second order, so y double dash is my 0 at the boundary points. Boundary points is my 0, 1. So you can easily check which other condition is satisfied. Clearly says this condition is satisfied, because if you look about the second derivative of this, it will be my 4x. So add the 0. If you look about this is a 2x plus, it can never be a 0. Here is, if you look about square, if you take the second derivative, it will be constant, it will not be a 0. Okay, which of the conditions remain here? So this is a function independent of the x. So we can start from this side, constant. So then f is remain constant, that's not true, that is not true. f minus y, that is not true. F minus y dash is the right answer of this problem. Okay, we can write this function in the simple x dot I can written as a y dash, and x I can written as a x. Then we can start with the extremal partial. Now this is my independent of y, so my extremal will be constant. Fine. So we can substitute here. It is a 2y dash over x cube is my c. So what is the y dash? Is c times x cube by 2. Now you can integrate them. Y is c by 2, x4 by 4. That is plus of constant. So x4 by 8 times constant plus b. So that means which involve x raised to power 4. This is x raised to power cube, cancel, cancel, cancel. X raised to power 4 is the right answer. You can find the c and b by using this condition. You will get c as my 8, b as my 2. But there is no need, there is only one correct option. Okay, now there is a partial derivative in this form. Now there is a ux, uy. That's a very simple. What is the partial derivative in this case is? This is u minus partial derivative with respect to x of, what is that? This is y dash. Now here is ux minus uy is 0. Now we can substitute the value. What is the f? This is my f. Partial derivative of u is e of xy. What is the partial derivative with respect to is ux. Partial derivative of uy is uy. So what is the right answer of this? Exy, uxx, uyy means here. So this option is correct. First option cancel out. This is a negative cancel out. This value is my 0. So right hand side is there. So the B and D are my correct options. Okay, look at this one. Here f is my y square, y dash square, which is independent of x. So we can start with this simple solution. Is my constant. So what is the f is? Y square, y dash square minus, what is the partial derivative? 2y square, y dash is constant. So what is that? This is a 2, it's a minus y square, y dash square is constant. So minus of c I can take as a c. So I can take the square root, I can consider as a. Now you can integrate this. It is y square over 2. It is ax plus b, which is the equation. That is a list of the parabola. So the right answer is C. Okay, this is the question related to the Feb 2022. That's again a very simple question. What you can do is you have to read the statement. Here this is the R cube, but whatever we have described here, this is in the R1 plane. So we can extend this equation to be the R cube. That's very simple. See, this is the equation we have used. Minus partial derivative f with respect to the y dash is 0. This is the Euler equation. Now what you can do is we can extend them to be the 2 dimensions. How you can do? I can written as partial derivative of, say, there is a function in terms of the u. This is for the 1 dimension. For the R cube, it is a x coordinate, y coordinate, z coordinate. So I can written as a gradient. How I can written as? What is the y dash? Y dash is nothing but my u partial derivative. This, and this. So I can written this as partial of gradient of u. This is my simple equation. Now look at that. This is my f. What is the partial derivative of f with respect to u? 0. So what is the meaning of that? This of is 0. What is the meaning of that? Now you have to find what is the meaning, how you can find this solution. How you can find that partial derivative of, you can find the partial derivative of f 1 plus gradient u square of this. So what is the partial derivative with respect to the gradient? So 1 over 2 is outside. This 2 times of this, it will be cancelled out. So what is the meaning of this is del dot of 1 plus of this is 0. So what is the meaning of that? You can see what is the del dot, what is the divergence? It is nothing but my divergence of this part. So the first option is correct. Clearly say that if the divergence is 0, that's the dot product is 0, it means this part should be a constant, but it is not always 1. If it is means, it means this is a C, but it is a 1, it is not always 2. So this is cancelled out. Now look about this one, look about the other options. So if I just clear this screen for you here. So what is the gradient of u? U, b is the unit of center at origin. So I simply take as a x square plus y square plus z square. What is the gradient of u? So we all know it's a 2x I cap, 2y j cap, 2z k cap. What is the absolute value of this? 4 times x square, y square, z square. So it is 2 times of x square plus y square plus z square. This is the right answer of this. Now, is the radius is given to you of the unit open ball? No. A unit ball. So radius is not given. So this is my 1. So what is the answer of this? It's a 2, but here is 1, which is not equal to 1. So this option is also cancelled out. How you find this? U of xi. If I consider u of this xi, that is my x, or you can simply take as of this. This is my u. So what is the partial derivative with respect to the x1? 2x1. Similarly, x2. What is the xi xj? 0. So this part is a 0. So this 2 only when I is equal to j. So what is the meaning of that? This is my ux1, 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 x1. So what is that? 2x1 of 2. So 2x1 of 2. This is for the I is equal to 1. So that is my 8x1 square. Similarly 8x2 square, and similarly 8x3 square. So you can see this number is my 8 times x1 square. This value we already computed as a 2. So it is my 5 times. What is that? This is, I think this is a statement is wrong, because this is should be, what is that? This is, it should be the nature of this. So this option is not be true. We can see the first option is correct. This term is not clear too. Again, here is a weak minima, strong minima, weak minima, strong minima. So what is the condition for that? Partial derivative is greater than 0, we call as a minima. Less than 0, we call as a maxima. What is that? F is y dash square minus y square. What is the partial derivative of y dash square? Is a 2, which is a greater than 0. So that means minima. It is always, so it's a strong minima. Strong minima implies my weak minima. So it's a maxima, strong, all are. So it means all are. Now condition is on the alpha. So we can find the solution. F is y dash square minus y square. So partial derivative with respect to here of this. How you can solve? Now since it is independent of x, you can also start from this, but I can write like this way. So it is 2y dash square. So y double dash plus y is equal to 0. So y is equal to c1 cos x, c2 sin x. When it is a 0 comma 0, so c1 is my 0. When it is alpha comma 0, so 0 is c2 sine of alpha. So c2 is a non-zero, so sine of alpha is my n pi. That is alpha is n pi. Fine. So what is the solution of this? So c2 sine of, that will be the n pi, in the nature of the n pi. So what is the meaning of that? Now is a, that is, this is a 0, this is a pi, this is a 2 pi. So corresponding to the c1, you have the different extremals are there. They are the different trajectories. If you taken about here, this one. Now what is the meaning of the v? Now you can see, if you start from here, because there is no point here, if you start from here, how many breaking points are there? From here there are the 2 breaking points, 1 and 2. But if you start on this interval when it is less than of the alpha, how many breaking point? 1. So whenever there is a condition of the v, we only need a 1 breaking point. So which case is there? There is only 1 breaking point. If I consider alpha as a greater than of the pi, then there are the 2 breaking point, one here, second this. So but for the weak we need a one breaking point corresponding to alpha less than pi, alpha less than pi. So the third and the fourth option cancel. Okay, so next one is, you can see this is independent of x and y. So what is the solution of my u? Is ax plus b. So once ax plus b, u of 0 is 0. It means b is my 0. Maximum of, so u is my ax. Fine. Now you can find the maximum of this. The maximum of this is occurring at the point 1 because it's a closed interval. So when x, that means u of 1 is 1. So what is my a? A is my 1. Fine. So therefore u is my, x is my extremal. Now you have to find the infimum. You can substitute the value here. U dash is 1. Answer is 1. So which is the right answer of this is my, this is the correct answer of this problem. Okay, this is a question we have already discussed in the part 1, but some student didn't clear, so I can recall this again. So f is my of this. Again, this is independent of x and y. So my u is ax plus b. Fine. What is given to you? U of 0 is 0. What is the meaning of that? B is my 0. U of 1 is my 0. So it means 0 is a times 1 plus 0. A is also 0. So what is my u? U is my 0. So if you substitute here, what is the right answer of this? Derivative is my 0. It is my 1. Now, is it small m or capital M? You have to check whether it's a maximum or minimum. How you can check that? You can take the second derivative of here. So what is that? First derivative, e raised to power minus u dash. So if I consider here, what is the first derivative is? Minus 1. Fine. If you take the second derivative, it will be my e raised to power, and which is always be a greater than 0. So that means it's a min, that's here. So you can see this value is either minimum or maximum. So what is the condition of that? So this, what is that? Is it, sorry, it's a square. It's a square. So what is the square of this? So you can take the second derivative. What is the first derivative? E raised to power minus here, minus of u dash. Now you can take the second derivative. Minus of 2 is outside. U dash is 1 and plus e raised to power u dash square and minus of u dash. Now at the point u is equal to 0, we can substitute here. What is the right answer of this? E raised to u dash is my 0. So this is 1. This is my 0. It is, which is less than 0. That's a maximum. That's my supremum. So this value is my m. So m is 1. M is attained. That's 2. Now small m. That's the minimum. But since there is only a unique extremal, so you can never get a infimum. As you can see, this is a maximum. So the m is attained, cancel out. M is 0, cancel out. M is 1, but m is not attained, and the lower limit is my 0. So it is my correct option. Okay, look at this one. F is my y dash square plus y dash cube, which is again independent of x and y. What is the solution of this y? Ax plus b. Once this is extremal, then there is, okay, what is a c1? One time differentiable. c2 two times differentiable. But this is a polynomial. This is a polynomial, so it is differentiable. All the orders are there. So now you can check about the options. There exists an extremal. Yes, there is existence of extremal in the c1, one time differentiable, but not the two times. That's the wrong option. Extremal in the c, but not in the c1. That's the wrong option. Every extremal is differentiable to the c1. Correct option. Every extremal is differentiable to c2. That's also the correct option. So c and d are my correct answers. Okay, now look at this. F is my y dash square minus of 2xy. Now we can apply the Euler equations. Partial derivative with respect to y minus of here. So 2 will be cancelled out. If I take as y double dash plus x is 0. Y double dash is my minus of x. Fine. Look at the options. So second derivative, so this fifth derivative can never be a linear. Fifth derivative can never be a linear. Now you can see about here. The second derivative of this will be a 0. Now the only part is my here. What is the second derivative? First derivative is here. Second derivative is my minus x. So this is the correct option. X3 by 7. The first derivative is my this. Second derivative is my minus 6 by 7x, which is not true. The right answer is only C is the correct answer. Okay, now we can consider here 3xy minus of y square. Which of the following is here? Okay, we can apply the extremal. So partial derivative minus of this derivative will be 0. So it means y is equal to 3 over 2x. Now we can check about the condition whether satisfied. Y of 1 is 3 by 2, which is not equal to 1. So it means this is not an extremal. So it means there is no extremal exists, because there is only one extremal obtained from this, but which is not satisfied this condition. Hence, moreover, y of 3 is not equal to 2. Hence, this is no extremal exists. Okay, look at this one. I can simply write this function as I can simply take, because this is the x dots, I can take it as a y square plus y dash square. Now we can take the partial derivative minus of here. So what is the meaning of that? 2 will be cancelled out. Y minus y double dash is 0. That means of this. So what is the meaning of that? So it means y is equal to c1, because m is my plus minus 1 e raised to power x of this. Now x of 0, what is the meaning of that is y of 0 is 0, y of 1 is 1. Y of 0 is 0 means c1 plus c2 is 0. Y of 1 is 1 means c1e, c2 over e is 1. So I can multiply this by e and add them. So what is that? C1e will be cancelled out. C2e, e minus 1 by e is minus 1. So C2 will be my minus e over e square minus 1. So what is the C1? E over e square minus 1 is the here. Now your target is to find the value of y half. I can substitute here C1 e square of half plus C2. C2 is my minus e and e raised to power minus half over this. So I can take this as a LCM. This is e, I can take it as a root. This is e raised to power 3 by 2, e raised to power plus 1 by 2. I can take e raised to power half common, e minus 1 over e square minus 1. So root e over e plus 1 is the right answer of this problem. That's a very simple question, Adi. Okay, last question here. So that is related to the 2021. So what is that? F is my 1 plus y dash square, which is independent of x and y. So what is the solution of this? So y is equal to ax plus b is my solution. Fine. Now look about the general solution. Now it's a constant c1 c2. So I can written this as c1x plus c2. Now we have to find the value of the c1 c2. So this is the point given to you. Y of half is 1 by 4. So I can written here half c1 plus c2. So what is that? 2c1 plus 4c2 is 1. First condition is satisfied. Okay, again this condition is also satisfied because the second point is my here. I can substitute this value, this y is equal to x minus 5, and this is c1x plus c2. This condition is also satisfied. This condition also satisfied if you compare this with here. What is that? C1 is my minus 1, C2 is my 3 by 4, and which satisfied here minus 2 plus 3 is 1, which is satisfied. So the right answer is also here. Now there is a condition of the transversal condition. What is that? What is the meaning of this transversal condition? That's very simple. That is f plus phi dash minus y dash partial derivative of this is my 0 is called as the transversal condition. What is the phi? Phi is my this one. Phi is my x minus phi. Fine. Now we can substitute here. What is the f? 1 plus y dash square. Phi dash, what is the derivative of this is 1. Y dash I can written as a simply y dash. What is the partial derivative of this? Sorry, this is square root also. So what is the partial derivative? Y dash over 1 plus y dash square is my 0. Clearly says that this at the right end. So that means you can see what is the y dash from here. What is the value of the y dash? That's a C1. So if I substitute here as a y dash is my C1, it satisfied this equation. So this is also the correct option. So all are my correct answers of this problem. So I hope you can simply learn the simple shortcut trick here. We will see the part 2 of the integral equation in our next lecture. Till then, you can simply follow my YouTube channel. You can simply like, share and comment on my videos. Best of luck students. Happy learning.